Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Muhammad Hafiz bin Muhammad Hazrami and my group members Muhammad Faiz Juny. We are from Cadbury Mantap. Today I will share about Power MOSFET. What is Power MOSFET? The Power MOSFET is a type of MOSFET. The operating principle of Power MOSFET is similar to the general MOSFET. The power MOSFETs are very special to handle the high level of powers. It shows the high switching speed, and by the comparing with the normal MOSFET, the power MOSFETs will work better. The power MOSFET is widely used in the N-channel enchantment mode, P-channel enchantment mode, and in nature of N-channel depletion mode. Here we have explained about the N-channel power MOSFET. The design of power MOSFET was made by using CMOS technology and also used for development of manufacturing the integrated circuit in the 1959. Device configuration. A power MOSFET is a special type of metal oxide semiconductor field effect transistor. It is specially designed to handle high-level powers. The power MOSFETs are constructed in a V configuration. Therefore, it is also called as a V MOSFET. The symbol of NP channel power MOSFET are shown in the below figure. Basic status of power MOSFET. Basic status of power MOSFET is divided by 3, which is on-state resistance, body diode, and breakdown voltage. On-state resistance. When power MOSFET is in on-state, then it produces a resistive behavior in between the drain and source terminal. The RS resistance is the source resistance. It will show on resistance between the source terminal of the package to the channel of the MOSFET. The RCH resistance is the channel resistance, and this resistance is inversely proportional to the channel width and for the given die size to the channel density. On-state resistance. Continue our slide. The axial resistance is represented by the RA. The axial resistance shows the resistance of the epitaxial zone directly to the gate electron. Rn represents the epitaxial layer and is used for the sustain the blocking voltage. This resistance is directly related to the voltage rating of the device. The high voltage MOSFET requires a thin low dependent layer which is highly resistive, and a low voltage transistor requires a thin layer with the higher doping layer which is very less resistive. Breakdown voltage. If it is in the off state and it is initiated by the P plus diffusion, the N epitaxial layer and the N plus substrate. When the MOSFET is in the on state, there is no function of the N layer. Moreover, it is lightly doped region. Intrinsic resistivity is non-negligible, and it is added to the MOSFET on-state drain to source resistance. Okay, for the body diode, MOSFET requires only that the source should be connected to an N plus zone. Thus, this will result in a floating P zone between the end source and drain. Under some conditions like high drain current in the order of the same volts of an on-state drain to source voltage, this is parasitic transistor or NPN should be triggered and make the MOSFET uncontrollable. Continue for body diode. The connection of the P implantation to the source metallization short the base terminal of the transistor parasitic to its emitter and is prevent the latching. For inductive load, the body diode utilize the freewheeling diodes in the configuration of H bridge of half bridge. Generally, this diode will have a high forward voltage drop. The current is high. They are sufficient in application like reducing part count. Power MOSFET characteristic. Once the voltage of the gate source is low as compared to the threshold voltage, then power MOSFET will be cut off region. To keep away from breakdown, the breakdown voltage from the drain to the source must be larger as compared to the voltage applied, so eventually breakdown will occur. The power MOSFET moves into the ohmic state, then the power dissipation is low in this region. Next, in the saturation state, the drain current is approximately independent of the voltage of drain to source. It is simply dependent on the voltage of the gate to the source terminal. The drain current will increase when the voltage from the gate source is increases. Application of Power MOSFET. The application of Power MOSFET include the following: UPS, relay driver, SMPS, industries, high frequency base inverter, used with power amplifiers in motor controlling and display driver. Future trend of device development. Electronics today come equipment with numerous features to increase their sale and provide comfort to consumers. Technology improvement in electronic components such as computer, smartphone, wireless communication, and cloud system, in order to improve safety of consumer, have within the opportunity for various safety and security products for vehicles. Got all that? If you have question, drop the question down below. Thank you for listening.